welcome to Introduction to Programming and C++ Concept. Well, today we will discuss the topic about C++ data types. But before that, let me introduce myself first. By the way, I am Analisa B. Polisca, BSIS 1B, and we are the group 3. Before I start in my discussion, what is data types? So, a data type is a classification of data which tells the compiler or interpreter how the programmer intends to use the data. Most programming languages support variables types of data, including integers, real characters, or strings, and boolean. So this is the examples of data types in C++. So we have primary, derived, user-defined. In primary, we have integers, characters, boolean, floating point, double floating point, and etc. In derived, we have function, array, pointers, reference. And user-defined, we have class, structure, and etc. So next. 3.1 C++ data types. When writing program in any language, you need to use various variables to store various information. Variables are nothing but reserved memory locations for storing values. This means that when you create an variables, you reserve some space in memory. You may like to store information of various data types like characters, wide characters, integers, floating point, double floating point, boolean, and etc. So based on the data types of variables, the operating systems allocate memory and decide what can be stored in the reserved memory. Primitive built-in types. C++ offers the programmer a rich assortment of built-in, as well as user-defined data types. Those data types are built-in or defined data types and can be used directly by the user to declare variables. For example, int, char, float, bol, and etc. The following examples list down 7 basic C++ data types. So this is the basic C++ data types. In types, we have boolean, characters, integers, floating point, double floating point, valueless, wide character. So in Boolean, data types is used for storing Boolean or local values. Boolean variables can store either true or false. So the keywords of Boolean is bool. The next one is character. Data types is used for storing characters. The keywords of the characters is char. Third, integers. So the keywords of integers data types is int. The next one is floating point. Data types is used for storing single permission. Floating points, variables, or decimal values. So the keywords of floating point is float. Double floating point. So the keywords of double floating point is double. Valueless means without any value. Valueless data types is used for those function which does not return a value. So the keyword is void. So the last type is wild character. So the keyword is vchar t. Several of basic types can be modified using one or more those types modifier. We have signed, unsigned, short, and long. Signed means a numeric variable is signed if it can represent both positive or negative. Unsigned if it can only represent non-negative numbers to zero or positive numbers, integers. Short is integers data types that occupies 2 bits of memory, long used for large integers equivalent to long int. The following table shows the variables types, how much memory it takes to store the values of memory, and what is maximum and minimum value which can be stored in such type of variable. So we have here typical bit, typical range. For example, char. The typical bit of char is 1 bit, and the typical range is -127 to 127 or 0 to 255. Unsigned char, 1 bit. The typical of unsigned char is 0 to 255. And another example is signed char. 1 bit is the typical range is 100. Another example is signed char. The typical bit of signed char is 1 bit, and the typical range is -127 to 127. The size of variables may be different from those shown in above table depending on the compiler and the computer you are using. The following is an example which will produce correct size of variables data types on your computer using namespace. So this is the examples of coding. This example use an I which insert a new line character after every line and left shift operator if being used to pass multiple values out to the screen. We are also using size of close and open operator to get size of various data types. When the above code is compiled and execute, it's produce the following result, which can be vary from machine to machine. So the result of coding is this: size of char 1, size of int 4, size of short int 2, size of long int 4, size of lat 4, size of double 8, size of char t equals to 4. Type def declaration. You can create a new name for an existing types using type def. Following is the simple syntax to define a new types using type def. Type def type new name. The compiler that fit is another name for int. Type def int fit. Now the following declaration is perfectly legal and creates an integer variable called distance. Fit distance. Enumerated types. Unenumerated types declarations, an optional types name, and a set of zeros or more identifiers that can be used as a values of type. Each enumerator is a constant whose type is the enumeration. Creating an enumeration requires the use of the keywords enum. The general forms of an enumeration types is enum and enum name, list of name, or list. Here, the enum name is the enumeration type's names. The list of names is comma separated. For example, the following code defines an enumeration of color called cold, cold colors, and the variable C of type color. Finally, C is assigned the value blue. Enum color is red, green, blue, and C. C equals to blue. But by default, that value of the first name is 0. The second name has the value 1, and the third has the values 2, and so on. But you can give a name a specific value by adding an initializer. For example, in the following enumeration, green will have well will have the value 5. Enum colors red, green equals to 5 blue. So yung blue meron siyang value na 6. Here blue will have a value of 6 because each name will be one greater than the one that process it. So that's all for my report, and we will proceed to the next report.
C++ variable types. What is variable? A variable provides us with new storage that our programs can manipulate. Each variable in C++ has a specific type which determines the size and layout of the variable's memory, the range of value that can be stored within that memory, and the set of operations that can be applied to the variable. In C++, a variable is a fundamental concept that provides a main storage location within a program. This storage can hold data, and the program can manipulate or retrieve this data as needed. Variables are crucial for storing information that programs use and process. The name of a variable can be composed of letters, digits, and the underscore character. It must begin with either a letter or an underscore. When you give a name to a variable, that name can only use letters, numbers, and underscores. But it has to start with a letter or an underscore, not a number. For example, variable name, my underscore variable underscore 1, 2, and 3. The letters my and the digits is 1, 2, and 3. There are following basic types of variables in C++. Number 1. Bool or Boolean. A bool is a data type that can store either the value true or false. Booleans are often used for making decisions in conditional statements and controlling the flow of a program. And this is the example of bool. This program demonstrates how Boolean variables can be used in numeric expressions where true is treated as 1 and false as 0. In this specific case, it calculates and prints the result of 2 times x plus y, which is 2. Number 2. Char. A char typically represented as a single octet or 1 byte, and it is considered an integer type. It is often used to store individual characters such as letters, digits, or symbols in text-based data. However, it's important to note that the exact size and characteristics of a char can vary between programming languages and platforms. And this is the example of char. This program simply declares a character variable, assigns it the value h, and then prints the value of that character along with some explanatory text to the console. When you run this program, it will display character equals to h as the output. 3. Int. The most natural size of integer for the machine. The natural size of an integer for a machine depends on the computer's architecture and is usually chosen to balance the need for representing a wide range of values with memory efficiency. Different machines may have different natural integer size, and this choice can affect how software performs and handles data. And this is the example of int. When you run this program, it will wait for you to enter an integer, and after you input 1, it will display that integer back to you. For example, if you enter 42, it will output you entered 42. Float. A single precision floating point value is a data type used in programming to represent decimal numbers with a limited degree of precision. In most programming languages, it typically occupies 32 bits of memory and can store numbers with a decimal point. Floats are used for a wide range of applications involving real numbers, but they have limited precision compared to double precision or other higher precision floating point types. This is the example of float. When you run this program, it will display the message float type number equals to 5.6937 on the console, indicating the value of the num float variable. Double. A double precision floating point value is a data type commonly used in programming to represent decimal numbers with high precision. It is typically written as double in many programming languages and occupies 8 bytes of memory, allowing it to store a wide range of values with significant decimal places. Double precision numbers have a higher precision than single precision floating point numbers, but require more memory. They are often used in applications where precision is critical, such as scientific calculations or financial applications. 6. Void represents the absence of type. In many programming languages, including C and C++ language, void represents the absence of a specific data type. It is often used as a return type for functions that don't return a value or for pointers that do not have a specific data type associated with them, such as void pointers, which can point to data of any type. And this is the example of void. This program demonstrates the use of a void pointer to store the address of a float variable and then uses typecasting to retrieve and print the value stored at that address. It's a simple example illustrating the concept of typecasting and void pointers in C++. A wide character type. Wide character type is often used in scenarios where text processing requires support for different character encodings and internationalization. It provides a way to represent and manipulate characters from various languages and character sets. And this is the example of wide character type. This program demonstrates the use of the wide character data type for working with wide characters and shows how to print a wide character and its size to the console. C++ also allows to define various other types of variables, which we will cover in subsequent chapters like enumeration, pointer, array, reference, data structures, and classes. Enumerations allow you to create a user-defined data type consisting of name, integer, constant. They are used to make the code more readable and maintainable by providing meaningful names to values. Pointers are variables that store memory addresses. They are essential for tasks like dynamic memory allocation and working with data structures like linked lists and trees. Pointers are a fundamental concept in C++. Arrays are collections of elements on the data type stored in contiguous memory locations. They allow you to work with groups of data efficiently and are often used for tasks like storing lists of items or numeric values. References are aliases or nicknames for existing variables. They provide an alternative way to access and manipulate the data stored in a variable. References are mainly used to make code more readable and avoid unnecessary copying of data. Data structures are user-defined types that allow you to organize and store data efficiently. Common data structures in C++ including arrays, linked lists, stack, queries, and trees. These structures are used to solve complex problems and manage large data sets. Classes are fundamental concept in object-oriented programming or OOP and C++. They allow you to define custom data types with their attributes and behaviors. Classes provide a blueprint for creating objects which are instances of the class. Variable definition. A variable definition tells the compiler where and how much storage to create for the variable. In C++, a variable definition informs the compiler about the variable's name, data type, and reserves memory for it. It specifies where and how much storage should be allocated to hold the variable's data. Here, type must be valid C++ data type including char, wildchar, int, float, double, bool, or any user-defined object, etc. And variable list may consist of one or more identifier names separated by commas. Some valid declarations are shown here: int ijk, char cch, float f, salary, double d. Variable declaration. A variable declaration provides assurance to the compiler that there is one variable existing with the given type and name so that compiler proceed for further compilation without needing complete detail about the variable. A variable declaration has its meaning at the time of compilation only. Compiler needs actual variable definition at the time of linking of the program. A variable declaration in the code provides the compiler with essential information about the variable's existence, type, and name, allowing the compiler to check for errors and proceed with compilation. The specifics of the variable's memory allocation and initial value are determined during linking. A variable declaration is useful when you are using multiple files and you define your variable in one of the files, which will be available at the time of linking of the program. In this C++ code example, there is a concept called variable declaration and variable definition, along with the use of the excellent keyword. Variable declaration. In the beginning, you see the lines int ab and int c. These lines declare three integer variables a, b, and c. The extend keyword tells the compiler that these variables are declared but not defined in this file. They are essentially placeholders indicating that these variables will be defined elsewhere in the program. Variable definition Inside the main function, you see the lines int AB and int C. These lines define three new variables with the same names as the ones declared globally, but they are local to the main function. These local variables shadow or hide the global ones with the same names within the scope of the main function. Actual initialization. The values of these local variables a and b are initialized within the main function with values 10 and 20. Then the local variable c is assigned the value of a plus b, which is 30. Another local variable f is defined and initialized with the result of 70.0 divided 3.0, which is approximately 23.333. Here are two kinds of expressions in C++, L value and R value. Expressions that refer to a memory location is called L value expression. An L value may appear as either the left-hand or right-hand side of an assignment. L values represent memory locations or objects that can be assigned a new value and can appear on both sides of an assignment. R value, the term R value refers to a data value that is stored at some address in memory. An R value is an expression that cannot have a value assigned to it, which means an R value may appear on the right but not left-hand side of an assignment. R values represent data values that are typically used on the right-hand side of an assignment to provide values to be assigned to L values. This distinction is important in low-level languages like C and C++ language because it helps define how variables and values can be manipulated in assignments and expressions. That's all.
Good day everyone. So our next topic is variable scope in C++. Variable scope. A scope is a region of the program where a defined variable can have its existence, and beyond that variable, it cannot be accessed. A scope is a region of the program, and broadly speaking, there are three places where variables can be declared. First, inside a function or a block, which is called local variables. Second, in the definition of function parameters, which is called formal parameters. Third, outside of all functions, which is called global variables. But before we proceed to the next topic, let's know or understand what is a scope in a variable. A scope is where the variable can be used or where the variable having its existence, while the variable is to store information or data. So, si variable is nag-store ng information or data, while si scope is nilalagay ni scope si variable kung saan ito pwedeng gamitin or saan pwede mag-access si variable. So, that is the scope and variable. So, next we have two types of variable scope, that is local variables and global variables. So, let's identify what is local and global variables. Local variables. Variables that are declared inside a function or block are local variables. They can be used only by statements that are inside that function or block of code. Local variables are not known to functions outside on their own. So local variables only access inside of the function. So next is global variables. Global variables are defined of all the functions usually on top of the program. The global variables will hold their value throughout the lifetime of your program, and the global variable is available for use throughout your entire program after its declaration. So global variables, anything outside of all function can access. So here's an example of local and global variable. As you can see, local variables are inside of the program, it only access inside or nagpa-function ang si local variable sa loob. While si global variable can access the entire program. So, pinakita ko lang itong example para mas malinaw kung ano si local and global. So, here's an example of local variable. So, hashtag include iostreams using namespace std. So, given a shower, this is the heater. It is used to perform input and output operations. So next is int main here. This is the main entry point of the program. Execution of the program starts from here. So dito na si local variable. So we're using int or integer. It defines for numbers because we're making a program using numbers. So in the main point, we have integer variables, that is int a and b. So it declares two integer variables named a and b. So we have another integer variable that is the int c. So the integer variable's name is c. So next is the actual initialization. In integer variable, we have a and b, so the value of a is 10 and the value of b is 20. So that is the variable of a and b. So c equals a plus b. This line adds the value stored in a and b and stores the result in c. So the value of c, which is the result of adding a and b, it displays on the console using coutstream. So return 0. This line indicates that the program has executed successfully and returns a status code of 0 to the operating system. So overall, this program calculates the sum of two numbers, that is 10 and 20, and display the result thirdly on the console. So that is the local variables. So here's an example of global variables and local variables. A global variable declares int g. This line declares a global integer variable named g. Global variables are accessible throughout the entire program, so it defines the main function. This is the int main. This is the main point of the program. Execution of the program starts from here. So it declares integer variable a and b, int a and b. This declares two local integer variable named a and b. Local variables are only accessible within the scope of the function in which they declared, in this case within main. So a equals to 10, b equals to 20. So these lines initialize a local variables a and b with the values of 10 and 20. So next is g equals a plus b. This line calculates the sum of a and b and stores the result in the global variable g. Global variable are accessible throughout the entire program, so you can use g here even though it was declared outside of main. So cout g. This line prints the value of g to the console using the coutstream. It will display the sum of a and b, which is 30 in this case. So that is global variables and local variables. So next is initializing local and global variable. When a local variable is defined, it is not initialized by the system. You must initialize it yourself. Global variables are initialized automatically by the system when you define them as follows. is int. When you declare an integer variable without assigning a value, it's typically initialized to 0 by default. Second, char. Similarly, an initialized character variables is often initialized with the null character. Third is float. An initialized floating point variables are commonly initialized to 0.0. Fourth, double. Double precision floating point variables like float are often initialized to 0.0 when not explicitly assigned a value. And fifth is pointer. An initialized pointer which holds a memory address is usually initialized to null. This indicates that it doesn't currently point to any specific memory location. So these default initializations provide a consistent starting point for variables in various data types, ensuring that our program doesn't contain unpredictable or random values when you haven't explicitly assigned them. So it is a good programming practice to initialize variables properly. Otherwise, sometimes program would produce unexpected results. And that's all. Thank you.
3. Introduction to Programming and C++ Concept. I am a Group 3. My topic is C++ identifiers. A C++ identifier is a name used to identify a variable, function, class, module, or any other user-defined item. An identifier starts with a letter capital A to Z or small letter a to z, or an underscores, open parenthesis, underscore, close parenthesis, followed by 0 or more letters, underscores, and digit 0 to 9. Ang C++ identifier, isang pangalan na ginagamit upang tukuyin ng isang variable, function, klase, modulo, anumang iba pang item na tinutukoy ng isang user. Ang identifier nagsisimula sa letrang malaking letrang A hanggang Z o maliit na A hanggang Z o isang zero o higit pang mga titik, underscores at digit. C++ does not allow punctuation characters such as at, dollar, and percent. Within identifiers, C++ is a case-sensitive programming language. Thus, manpower and manpower are two different identifiers in C++. So, hindi pinapayagan ng C++ ang mantas na character gaya ng sign ng at, dollar, and percent. Sa loob ng mga identifiers, ang C++ ay isang case-sensitive na kaya ang manpower at manpower ay dalawang magkaibang identifier sa C++. Here are some examples of acceptable identifiers. Mode, Zara, ABC, move underscore name, A underscore 123, my name 50, underscore temp, J, A23, B9, retval. Ito yung mga example ng mga na accept ng isang identifiers. The next is C++ keywords. The following list show the reserved words in C++. These reserved words may not be used as constant or variable or any other identifier names. Ang keywords ng C++ sumusunod sa listahan ay nagpapakita ng mga nakalaan na salita sa C++. Ito yung mga nakakaserbang salita na hindi maaaring gamitin bilang pare-parehong o variable o anuman iba pang pangalan ng identifier. There are an example of keywords: ASM, auto, ball, break, case, catch, char, else, enum, explicit, export, extern, false, float, new, operator, private, protected, public, register, reinterpret cast, this, throw, true, try, type it def, type ID, type name. The next is class, cons, cons cast, cons underscore cast, continue, default, delete, do, double, dynamic underscore cast, for, friend, goto, if, inline, int, long, mutable, namespace, return, short, signed, size of, static underscore cast, struct, switch, template, onion, unsigned, using, virtual, void, volatile, wchar underscore t, while. Thank you for listening.
So good day everyone. So I'll be tackling about 3.2 operators in C++. An operator is a symbol that tells the compiler to perform specific mathematical or logical manipulations. C++ is rich in built-in operators and provide the following types of operators. These are arithmetic operators, relational operators, logical operators, bitwise operators, assignment operators, and means operators. There are following relational operators supported by C++ language. Assume variable A holds 10 and variable B holds 20, then negative. Arithmetic operators. If the operator is plus, the description is add two operands. Example, A plus B will give 30. When the operator is negative, subtract second operand from the first, then A minus B will give negative 10. If this is the operator, multiplies both operands. Example, A times B will give 200. If this is the operator, divides numerator by the numerator. B divided by A will give 2. And so on. Relational operators. When the operator is double, checks if the values of two operands are equal or not. If yes, then condition becomes true. Example, A double equals to B is not true. If this is the operator, check if the values of two operands are equal or not. If values are not equal, then condition becomes true. Example, A is equals to B is true, and so on. You might want to check the other relational operators. Logical operators. There are following logical operators supported by C++ language. Assume variable A holds 1 and variable B holds 0, then negative. Operator double and The description is called logical AND operator. If both the operands are non-zero, then condition becomes true. Example, A, double and to B is false. And also you might want to check the other logical operators. Just pause the video so you can check it. The bitwise operators. Bitwise operators works on bits and perform bit-by-bit operation. The truth tables for AND are as follows. Assume if A is equals to 60 and B is equals to 13. Now, in binary format, there will be as follows. A is equal to 00, 11, 11, 00. B is equals to 00, 0, 1101. The bitwise operators supported by C++ language are listed in the following table. Assume variable A holds 60 and variable B holds 13. Then, if this is the operator, the description is binary and operators copies a bit to the result if it exists in both operands. Example, A and B will give 12, which is 00001100. Just pause the video if you want to further more examples. Assignment operators. There are following assignment operators supported by C++ language. Like for example, operator equals. The description is simple assignment operator assign values from right side operands to the left side operand. Example, C is equals to A plus B will assign value of A plus B into C. Another example is operator plus and equals. Add and assignment operator. It adds right operand to left operand and assign the result to left operand. Example, C plus equals A is equivalent to C equals C plus A. Just pause the video if you want more examples. The MIS operators. The following table lists some other operators that C++ supports. Number 1. Size of operators returns the size of a variable. For example, size where A is an integer and will return 4. 2. Conditional operators. If condition is true, then it returns value of x, otherwise returns value of y. Number 3. Comma operator causes a sequences of operations to be performed. The value of the entire comma expression is the value of the last expressions of the comma separated list. Number 4. Member operators are used to reference individual members of classes, structures, and unions. Number 5. Casting operators convert one data type to another. For example, 2.2000 would return 2. Number 6. Pointer operators and return the address of a variable. For example, will give the actual address of the variable. Pointer operators is pointer to a variable. Operators precedence in C++. Operator precedence determines the grouping of terms in an expression. This affects how an expression is evaluated. Certain operators have higher precedence than others. For example, the multiplication operator has higher precedence than the addition operator. For example, x is equals to 7 plus 3. Then 2 here is x is assigned 13, not 20 because operator has higher precedence than plus. So it first gets multiplied with 3 times 2 and then adds into 7. Here, operators with the highest precedence appear at the top of the table. Those with the lowest appearance at the bottom within an expression, higher precedence operators will be evaluated first. Just pause the video to see the table. That would be all. Thank you.